Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In this video, we are going to learn how to find the square root of any number by long division method. In the previous video, we have learned how to find the square root by prime factorization method, which was very simple. Now we are going to use long division method, and this method is particularly applicable when the given number is not a perfect square. So it is applicable for both perfect squares as well as non-perfect squares. Let us get into the details of it. So we are going to learn about square root by long division method. This method is applicable for both perfect squares and non-perfect squares. Whereas prime factorization method was not helpful to find the square root of a non-perfect square, whereas long division method will help us in that way. Let us get into the details of it. Initially, we will find out the square root of a perfect square using long division method, which makes us comfortable, and then as we get acquainted with the method, we will move on with the non-perfect squares. 576. This is going to be a perfect square. We are going to find out the square root of 576 by long division method. Let us follow step by step. The first step is pairing. Pairing of numbers. This is a procedure to pair the numbers. We are going to start pairing up the numbers from right to left. Here 5 is left without a pair, so I will write it as 0, 5, 7, 6, which does not change the value of the number. If at all I have 5, 0, 5 doesn't change the value of a number. That means putting a 0 towards the left of it doesn't change the value, whereas if I do so, yes, its value has changed. So this is not applicable, right? So we have paired it up in this way. Now I am going to use long division method in finding out the square root of 576. So 5 is the initial number. I am going to choose a perfect square which is less than 5. 2 square is 4. 3 square is 9. So 4 is a suitable number here. 2 2s are 4. I am going to subtract. 5 minus 4 is 1. Unlike the normal division where we bring down one digit, here we are going to bring down a pair of numbers. 76, and this is going to be 4 here. First step, pairing of the numbers. Second step, we are going to choose the first pair and choose a perfect square less than that. 2 2s are 4, and add 2 to it. So we are going to get 4, and this one's digit is going to be left over. Here I can write any digit right from 0 to 9 here. But the condition is, if I put a 0 there, it becomes 40. I am going to multiply with 0. 40 zeros are 0. If I put a 1 over there, I need to multiply with 1. 41 ones are 41. If I put a 2 over there, it becomes 42. I have to multiply with 2. If I put a 3, it becomes 43. I need to multiply with 3. This is the condition. 3 3s are 9. 3 4s are 12. So if I put a 4 here, I need to multiply with 4. 4 4s are 16, 4 4s are 16, 176. So how do I make a wise choice here? Should I go on repeating all these, or can I get a shortcut procedure? Yes, there is a shortcut procedure. The last digit has to be observed. Here it is 6. 2 2s are 4. So it is not going to be applicable for 42. 3 3s are 9. Observe that 4 4s are 16. So 44 may be a wise choice, may be a wise choice. We will check with 44. If that doesn't work out, then we will move on to the next pair of next number, suitable factor. 44 into 4 is 176. So we have multiplied with 44. The square root of, hence square root of 576 is going to be 24. This is a procedure of long division method. This is the way we find out the square root of the given number using long division method. Here 576 is a perfect square. I repeat the procedure step by step. First step, we are going to pair up the numbers starting from right to left. 6 7, 76 is one pair, and 5 0 5 is a pair. Right, that first step is done. Second step, choose the first pair of numbers. Here it is 5. What is the perfect square closer to 5, less than 5? 2 2s are 4. Towards the right hand side of the line, we are going to subtract. 5 minus 4 is 1. Towards the left hand of the line, you are going to write down the same number and add it. 2 plus 2 is 4. So, leave the ones place blank and write the 4 here. Here in this ones place, we are free to write any digit right from 0 to 9. But the condition is, if you put a number digit here, you have to multiply this number with the same digit. So, we tried all the digits and 4 worked out. So, 44 4s are 176. Therefore, square root of 576 is 24. We will move on to the next example. Now, do we get the same answer even with the prime factorization method? Let us work out. 576, as we have observed, it is going to be a perfect square and it is divisible by 2 here. 2 2s are 4, 2 8s are 16, 2 8s are 16. Then again 2 144s are, 2 7s are, 2 2s are, and 2 36s are, 2 18s, 2 9s and 3 3s. So, let us observe whether we have got pairs of prime numbers or not. Yes, we have got pairs of prime numbers. So, root of 576 is, from each pair we are going to choose one representative here. So, 2 into 2 into 2 into 3. 2 2s are 4, 4 2s are 8, 8 3s are 24. So, we have got the same answer by using both the procedures, that is prime factorization method or long division method. Prime factorization method will work out to find the square root only for perfect squares, but long division method will work out for non-perfect squares also. Let us move on to the next example. Let us choose 7056. We do not know whether it is a perfect square or not. Let us check it out. Let us find out the square root of this by long division method. If we observe the steps, first step is pairing of the numbers. That too we need to pair from right to left. So, 70. 1 square is 1, 2 square 4, so on. We need to find out the perfect square which is less than 70. 7 7s are 49, 8 8s are 64, 9 9s are 81. So, 64 is going to be the suitable number. So, 8 8s are 64. Towards the right side of the line, we need to subtract, and here we need to write down the same number and add, leaving away the ones place. 8 plus 8 is 16. 70 minus 64 is going to be 6. We need to get the next pair of numbers down, and we remember the condition that I can put any digit here but follow one condition, and the condition is you have to multiply with the same number. Let me guess what can be the suitable number. Here I need 6. 4 4s are 16. 5 5s are 25, 6 6 are 36. So, it can be either 164 or 166. Let us try. If I multiply 164 with 4, what do I get? 4 4s are 16, 4 6 are 24, 25, 4 1s are 4, 6. Yes, this is suitable. So, I will not check with 166 at all. 164, 4s are 656. Therefore, square root of 7056 is 84. Right? Let us move on to the next example. Before that, let me quickly recap what is the procedure here. We have chosen a number 7056 and we need to find the square root of this number by long division method, and I started step by step. The first step is pairing of the numbers. We have done pairing from right to left. 56 is one pair and 70 is the next pair. Then I have chosen the first pair, which is 70, and the perfect square less than 70 is 64. 8 8s are 64. Then towards the right side of the line we need to subtract. 70 minus 64 is 6. Towards the left side of the line we need to add the same digit. So, 8 plus 8 is 16. I left out the ones digit empty. I am free to put any number, any digit here, provided I multiply with the same digit over there. I guessed 162, 2 2s are 4, so that may not help me. 3 3s are 9. I need 6 in the digits, 1th digit place. So I tried with 164 into 4, 656. It worked out. In case if it doesn't work out, I would have tried with 166 into 6. Reason is 6 6 are 36, which is also ending with 6. But here we don't have to do that because 164 into 4 is 656. Hence, square root of 7056 is 84. Let us move on to the next example. (1,444). Even this one we do not know whether it is going to be a perfect square or not. Let us try. Step 1, pairing of the numbers from right to left. Second step, choose the first pair and select a perfect square which is less than the given pair. Here 14 is the pair of number, 14 is the number. The perfect square less than 14 can be 4, 9 and 3 3s are 9, 4 4s are 16. So 9 is going to be 3 3s are 9, 4 4s are 16. We have to be thorough with the perfect squares of numbers from 1 to 10, 1 to 20 actually, right. So 16 is going to be a bigger number, so let me choose 3 3s are 9. Done. Second step is also done. Then towards the right side of the line we need to subtract. 14 minus 9 is going to be 5 and here I need to add 3 plus 3 is 6. I leave away the 1's digit place blank and continue with this. Then third step, bring down the next pair of numbers, 44. 4 is the required digit. So let us try with 2. 2 2s are 4. 2 2s are 4, 2 6 are 12. No, this didn't work out. 2 2s are 4, 3 3s are 9, 4 4s are 16, like that. Which is the number whose square ends with a 4 in 1's place? Yes, 8 square is 64, isn't it? So let us try with 68 into 8. 8 8s are 64. 8 6 are 48 plus 6 is 54, right. So that was a good choice. So 68 into 8 is going to be 544. Instead of doing all the digits, this guesswork will help us a lot in saving the time. This is going to be saving the time. So we have got square root of 1444 as 38. This is the procedure of long division method to find the square root of perfect squares. Okay. What if the given number is a non-perfect square? How do we find the square root? Let us choose a simple example. 140. Just in the previous examples we have checked 144 is a perfect square. So 140 is not a perfect square, we know that. Let us find out the square root of 140 using long division method. The first step, pairing of numbers. Here 1 is going to be alone, it can be written as 0 1 or 1 as such. Okay. How do we find the square root of this? What is a perfect square less than 1? 1 itself. 1 1s are 1, right. Here if I have to subtract, I get 0. I need to add, leave the 1's place, 1 plus 1 is 2, right. I have to bring the next pair of number down, 40. Here 21 1s are 21, okay. 22 2s are 40, 2 2s are 4, 2 2s are 4, 44, which is going to be bigger than this. So I have to choose only 21. 21 1s are 21. Then towards the right side of the line we need to subtract. 40 minus 21 is going to be 19 plus 1. 21 plus 1 is 22. Remember, we have to leave 1's digit as blank because I am going to make a choice here. We need to make a choice of digit here which is going to be suitable for the given number. So it's going to be 22 and a blank. Now 19 is there. 19 is always less than 22, no doubt about it. So how do I continue the process of long division here? In such cases, I put a point. Like normal divisions where we can't, the dividend is bigger than the divisor, smaller than the divisor, we continue with the decimal over there. Okay. Now how do I continue? I will put a point and write it as 0 0. I cannot write a single 0, it should always be a pair of zeros. Square roots, we need to remember that. So once I put a decimal point over there, I am free to bring down a pair of zeros. So 22 blank. what is the suitable digit in the ones place. Here how do I make a choice is the question. I require 1900, 200, approximately 200 is here. 200 into 8 is going to be 1600. 200 into 9 is going to be 1800. So it should be either of 8 or 9. Let us try with 8. 8 8s are 64. 8 2s are 16 plus 6 is 22. 8 2s are 16 plus 2 is 1824. So definitely 229 into 9 is going to be bigger than 1900. Let us check it. 9 9s are 81. 9 2s are 18 plus 8 is 26. 9 2s are 18 plus 2 is 20. 2061. As I said, 229 into 9 is bigger than 1900. So this is going to be a better choice. Perfect choice. So it's going to be 1824. Now again subtract. 1900 minus 24. It's going to be carrying over. So 10 minus 4 is 6, 9 minus 2 is 7. So we get 76. So this procedure continues. Every time you have a decimal point over there and we can bring down a pair of zeros. If we continue the procedure, 8 plus 8 is blank in the digits place. This has to be remembered very carefully. 8 plus 8 is 16. 236 is going to be the number. Here we have 7600. Suitable number 7000, 2000. 2000 into 2 is going to be 4000. 2000 into 3 is going to be 6000. So approximately 3000. That is the way we need to guess. We need 7600. What happens if I take 2 here? It's going to be near to 4000. 2 2s are 4, 2 6s are 12, 2 3s are 6, 7, 2 2s are 4. It's going to be very smaller than this. What if I take 3? 3 3s are 9, 3 6s are 18, 3 3s are 9, 10, 3 2s are 6, 7. Yes, a bit closer to it. If I take 4, it's going to be 8000, which is 2000 into 4 is always 8000, and it's going to be definitely more than this. So 4 is not going to be the better choice here. 3 is the choice. 7089. I continue. This is going to be continuous procedure. This is the way we are going to find out the square root of a non-perfect square using long division method. So let us quickly recap what all we have learnt in this video. In the earlier videos, we have learnt how to find the square root of a given number using prime factorization method. In this video, we have learnt how to find the square root of the given number by long division method. The prime factorization method was helpful to check whether the given number is a perfect square or a non-perfect square, but it did not enable us to find out the square root of a non-perfect square. This is a procedure which will enable us to find out the square root of a perfect square or a non-perfect square. In the previous example, we have chosen a non-perfect square and we found out the square root of the given non-perfect square. It was in decimals. Of course, it was a continuous process. After 2 or 3 decimal places, according to the question given, if we have to round it off to do 2 decimal places, we are going to continue till 3 decimal places and round it off, and accordingly. So this is what we have learnt in this video. A long division method which is going to be useful to find out the square root of a given number, be it a perfect square or a non-perfect square. Let us continue in the next video. Thank you.